China is winning the robot race. The US isn't even competing in it. There are two races happening in artificial intelligence right now, and almost all of the public attention is going to the wrong one. The race everyone watches is the race for the best model. Which chatbot is smarter? Which lab has the most impressive benchmark? That race is dominated by American companies, and if that were the only thing that mattered, the United States would be comfortably ahead. But there is a second race, and it is about putting artificial intelligence into a physical body that can move, lift, walk, and work in the real world. In that race, the numbers are not close. In the first half of 2026, Chinese manufacturers accounted for more than 97% of all humanoid robots shipped globally. 97%. And what I want to do today is explain exactly how that gap opened, why it is structural rather than temporary. And then, because this is the part almost nobody covers honestly, show you the serious reason the headline number is misleading and what the race actually looks like once you account for it. Stay with me, because the counterargument at the end genuinely changed how I read this story. Let me start with the raw scale, because the numbers are difficult to believe until you sit with them. Global humanoid robot shipments in the first half of 2026 reached approximately 19,100 units. That is a 272% increase year over year. The market roughly quadrupled in 12 months. Of those units, Chinese manufacturers shipped over 97%. Now compare individual companies, because this is where the gap becomes visceral. Morgan Stanley calculated that the Chinese firm Robotics shipped roughly 36 times more robots than its American competitors. Not 36% more, 36 times. Tesla, Figure AI, and Agility Robotics, the three most prominent American humanoid companies, each shipped approximately 150 units in 2025. Unitree, based in Hangzhou, shipped around 5,500 in the same period, and its chief executive has forecast between 10 and 20,000 deliveries for 2026. And China's own industrial ministry projects that total national humanoid output in 2026 will exceed 100,000 units, roughly 5 times the 20,000 produced in 2025. I want to isolate one number that I think tells the whole story better than any of the others. Price. Unitree's G1 humanoid now sells for around $12,600. Its R1 model starts at approximately $4,000. 3 years ago, machines of remotely comparable capability cost in the hundreds of thousands. That is a price decline of over 95% in 3 years, and a teardown analysis by China Post Securities found the base model still carries a gross margin above 40%. They are not selling at a loss to buy market share. The manufacturing cost genuinely collapsed. So how did this happen? Because the interesting question is not that China is ahead, it is why the gap is so wide, so fast, in a technology where American AI research is clearly excellent. The answer is that humanoid robots are not really an AI product. They are a manufacturing product with AI inside, and those are entirely different industrial problems. Think about what a humanoid robot physically is. It is a few dozen actuators, which are precision motors with gearboxes. It is harmonic reducers and planetary reducers. It is force sensors, torque sensors, cameras, batteries, control boards, structural frames, and a large amount of wiring. Every one of those components is a manufacturing item. Every one of them needs suppliers who can produce at volume, at quality, at declining cost, with fast iteration cycles. And that is precisely the industrial capability China spent 30 years building for other reasons. The consumer electronics supply chain in Shenzhen, the electric vehicle supply chain across the eastern provinces, the battery industry, the precision motor industry. All of it turns out to be almost exactly the input set a humanoid robot requires. One Shenzhen robotics executive told state media that more than 90% of the key parts for his company's humanoids are now sourced domestically. Compare that to the position of an American humanoid startup. The AI is world-class. The design work is excellent. But when it comes time to source 3,000 precision actuators at a price that makes the robot commercially viable, the supplier ecosystem largely is not there, and building it takes years and enormous capital. you end up importing components, frequently from the same Chinese supply chain you are competing with. This is why I called the gap structural, rather than temporary. It is not that American engineers are behind. It is that the bottleneck moved from software to hardware, and hardware advantage takes a decade to build, not a funding round. There is a second factor, and it is more deliberate. The Chinese government designated robotics and embodied intelligence a strategic priority, alongside AI and innovative medicine. Late in 2025, the Industrial Ministry established a standardization committee for humanoid robotics, and in early 2026, China released a comprehensive standards framework covering the full life cycle and supply chain. On top of that, came a direct instruction to industry. By the end of 2026, 10,000 humanoid robots must be actively deployed in factories, warehouses, hospitals, and disaster response. Not demonstrating, not running marathons, working. Set aside what you think of industrial policy for a moment and notice the mechanism. A standards framework reduces uncertainty for suppliers, which unlocks investment. A deployment mandate creates guaranteed demand, which justifies capacity expansion. And capital followed. Financing across the Chinese humanoid sector reached 68.1 billion yuan in the first quarter of 2026 alone, exceeding the entire previous year. So that is the case that China is winning. And if I stop the video here, you would come away thinking the race is essentially over. A lot of coverage does stop here, but it would be a bad video because there is a genuinely serious counter-argument, and once you understand it, the picture changes substantially. Here it is. Shipping a robot is not the same as the robot doing useful work, and the deployment data is far less impressive than the production data. Through the third quarter of 2025, more than 70% of Unitree's humanoid robot revenue came from research and education customers. Industrial applications accounted for only about 9%. Roughly 17% went to commercial venues, tourist sites, exhibitions, retail displays. Which means that of all those thousands of robots shipped, the substantial majority went to universities, research labs, and developers who bought them to build their own AI and motion control systems. Read that again, because it is the most important sentence in this video. The modern humanoid industry is, to a significant extent, selling robots to people who are trying to build better robots. That is a real market and a genuinely important one for advancing the technology, but it is not the same as machines replacing labor in the economy, and there is a capability reason for that, not just a market maturity reason. Today's humanoid robots operate at roughly 30 to 50% of human efficiency for general factory and warehouse tasks like stacking and carrying boxes. That number is the whole ballgame. A machine at 40% of human efficiency that costs $12,000 is interesting. A machine at 120% is a transformation of the global economy. The distance between those two states is not a manufacturing problem. It is an AI and control problem, which is precisely the domain where American labs are strongest. The industry has started calling 2026 the year of delivery, and the actual delivery evidence is early and mixed. UB-Tech's Walker S-Series passed a 3-month on-site validation at an automotive plant and earned mass production qualification, with an initial batch of 20 robots integrated into production doing door lock inspection and seatbelt installation. That is real, verified, useful work, and it is 20 robots. Meanwhile, the same manufacturer ranked third in production but fourth in shipments, which typically indicates inventory building up faster than it moves. So the honest scorecard looks like this. China has decisively won the manufacturing and cost race, and that lead is structural and likely durable. Whether anyone has won the capability race, whether these machines can actually do valuable work at scale, is genuinely undecided, and that question will be settled by AI and control software, where the competitive picture will be very different. Now let me connect this to something I argued on this channel a while back, because I think intellectual honesty requires it. In a previous video, I made the case that physical work in unpredictable environments is one of the most automation-resistant categories of human labor. I used the example of a plumber arriving at a house nobody has a diagram for, diagnosing by feel and sound, and improvising a fix. I still think that argument holds. But I want to be precise about what this new data does and does not change about it. It does not change the plumber example. A humanoid robot at 40% of human efficiency in a structured warehouse is nowhere near diagnosing a leak in a stranger's crawl space. What it does change is my confidence about the timeline for the more structured end of physical work. Repetitive, predictable physical tasks in controlled environments, factory lines, warehouse logistics, some parts of construction and cleaning are closer to automation than the software-only picture suggested, because the hardware cost curve is collapsing much faster than most people realized. The category is still resistant. The resistant zone is smaller than I would have drawn it a year ago. That is the honest update, and I would rather give you that than pretend my earlier framing was complete. So what does all this mean practically? If you work in or around manufacturing, logistics, or industrial operations, this is the development to watch, and the meaningful signal is not production numbers. It is the ratio between industrial deployment and research sales. When that 9% industrial share starts climbing steeply, that is the moment the technology crosses from promising to transformative. Watch that number, not the headline shipment figures. If you are thinking about the geopolitical picture, the useful frame is that these are two separate races with two separate leaders, and the winner of the combined contest depends on which bottleneck turns out to be harder. If robot capability is mainly limited by physical hardware, China's advantage compounds. If it is mainly limited by AI and control, the American position is much stronger than the shipment numbers suggest. Reasonable people disagree about which it is, and anybody who tells you it is obviously settled is not being straight with you. And if you are just trying to understand where this goes, here is the thing I keep coming back to. Almost everyone is watching the wrong scoreboard. Model benchmarks are visible, frequently updated, and easy to argue about. Actuator supply chains and deployment ratios are boring and largely invisible, but the boring numbers are the ones that will determine what actually shows up in the physical world over the next decade. That is what this channel is for. Finding the number that matters underneath the number everyone is quoting. If that is useful to you, subscribe and hit the bell, because we do this every week. And if you want the fuller argument about which kinds of work resist automation and why, watch the video I mentioned on the jobs AI cannot take. It is linked in the description, and it pairs directly with this one. Tell me in the comments which bottleneck you think decides this, hardware or intelligence. I read every single one. See you in the next video.